Hello everybody. I've had a few questions about how to fill out Part B Weak Electrolyte Table, and so I decided to make this video to show you guys. The first thing I did was go ahead and fill in all the values that have already been given to us. So if you look at the initial PDF, you can see that for the acetic acid, the weak electrolyte, we first prepared a 2.5 times 10 to the negative 1 molar, then 10 to the negative 2 molar, 2.5 times 10 to the negative 3 molar, 2.5 times 10 to the negative 4, and 2.5 times 10 to the negative 5 molar solutions. Okay. Next, I went ahead and filled in the data that was given to me for lab flow as provisional data for what those measured conductivities were. The real question is, how am I going to fill out these two columns? And in order to do that, I first need to take a look at the percent ionization equation and then make two assumptions. The first one being the most dilute solution is 100% ionized. This is a result of Le Chatelier's principle. You're going to learn about that in lecture. What that's going to let me do is come up to this most dilute solution, 2.5 times 10 to the negative 5, come over here to percent ionization and just put 100% right in there. Now, looking at this equation, in order for this to be 100%, then the measured value here needs to be the same as the theoretical value that I'm going to place into here. Okay, in order for this ratio to be 1. So I can just make that the same as the other one. Okay. Now to fill in the rest of these values, we're going to have to go to our second assumption. A 10 times increase in concentration leads to a 10 times increase in conductivity, at least in theory. So if we come up here, if this one is 10 times more concentrated than this one, then the conductivity I should have got should be 10 times this one, or 80. Similarly, if this one is 10 times more concentrated than this one, then this should be 10 times more conductive than this one. And then we can just fill the table out as we go up. Each time multiplying the last value by 10. Now, to have to go back to the percent ionization equation. And we can get out our calculators now and take the measured values divided by the theoretical values and multiply them by 100%. This first one here, we're going to have 25 divided by 80 times 100%. We get 31.25, 31.3%. As we see, our percent ionization went down as we became more concentrated. This is exactly the type of trend that we would expect to happen when we're dealing with a weak electrolyte. And that's it. We filled out the table.